commitment to a meeting in London at the moment. But I'm delighted to be able to take you through, with Mikiko, the science behind figure SBM1, which is the basis that sort of illustrates the scientific basis for the statement that we are now at 1 degree, warming at 0.2 degrees per decade, and reaching 1.5 degrees at the current rate of warming around 2040. So I'll start off just focusing on the left-hand side of this figure, which shows the observed evidence that we are now at 1 degree. So I'll start with the observations. Can we go to the next slide, please? Yep, so thank you. You're reading my mind very well there. Well done, Robin. And so this actually just illustrates the 4 observational data sets we used in this report. These are the available published global data sets. And if you go to the next slide, the first thing we did was just to express these as an average of the 4 data sets. And the grey line here, the range of the grey line shows the range of the data sets is quite small. We're showing you here the data expressed as monthly anomalies, so you can see how much the fluctuation there is from month to month. And you can see that even in 2016, there was actually a single month when temperatures briefly fluctuated over 1.5 degrees. The figure here also illustrates in that grey band on the left there, the period that was used based on the IPCC Fifth Assessment Report as a reference period, as representative of pre-industrial conditions. Obviously, 1850 to 1900 does not predate the industrial era, but because of a number of volcanoes which went off during that period, it is representative of pre-industrial global temperatures. I'm getting the occasional sort of duck quack on the line. Are you getting that too, or is it just me? Oh, you can hear me okay, can you? Okay, the ducks are clearly from one way. Okay, that's fine. I'll just keep going. Not worry about the ducks. Okay, so the first thing, as Mikiko mentioned, the first challenge we have is defining climate in a changing world. And so if we go to the next slide, which I think you've already got up, one with the red lines, that's great, thank you. Traditionally, the World Meteorological Organization has defined climate as the average over a 30-year period. But as you can see straight away from this figure, this introduces a problem, because if we define climate today as the average over the past 30 years, we would get the global temperature too cool. So the way we define climate in the SR1.5 report to deal with the fact that we are living in a warming world is to, if you hit return, please, to show the blue dotted line, that's right. We define the climate of today as the estimate of the 30-year average we would get, centered on today, assuming the current rate of warming continues throughout that period. So you can see immediately that part of that average is in the future, 15 years of it, in fact. So it's something we have to estimate. It's not something we can measure directly, but it's very important that we do estimate it in this way, because if we just use the average over the past 30 years, we would end up with an estimate of today's climate that was a couple of tenths of a degree too cold. And so that would give us a misleading impression of how close we are to 1.5 degrees. So I'm now going to take you through how we estimate the level of warming today. So go to the next slide. We know, we can use a bit of physics here, because we know the things that are driving change in global temperatures. The yellow lines here, if you hit return, are possible responses to greenhouse gas and aerosol emissions. There's 2 yellow lines there, because we don't know how big the response is to greenhouse gases and aerosols. So I've just put up a couple of possible sizes of those responses as examples. Hit return again. We also have contributing variations in the power output of the sun, shown in that little panel at the top there. Notice the sun has actually been going down slightly since the early 1990s on almost all measures. And we also have explosive volcanic eruptions, which cause those temporary cooling spikes in the global temperature record, which you can see in the blue lines there. So we know the observed temperatures are some combination of these anthropogenic, human-induced, and natural changes in climate, But crucially, models alone don't tell us how big these responses are. So what we do, if you go to the next slide, is we estimate the size of these changes from the observations themselves. And in principle, what we're doing is like fitting a trend, but we are accounting for the fact that we don't expect the trend to be a straight line. We know that there will be wiggles in it, and we use the information we have about the timing of those wiggles to estimate the level of warming we are seeing today, both due to human influence and due to the combination of human factors and natural changes, which is shown by the red line there. So crucially, you'll notice I haven't really used any complex climate models here. I've just used the information, or we've just used the information that's provided by the timing of greenhouse gas emissions, volcanic eruptions, and variations in the sun. So our estimate of the size of human influence on climate does not depend on climate models. It depends on observed global temperature changes and observations of the large-scale drivers of climate change. That's very important to remember. On to the next slide. It's also important to understand what we mean by global average surface temperature. This is something which sounds very detailed, and it is a sort of detailed issue, but it's something which came out as very important in the context of the 1.5 degrees report. If you hit return, please, the blue dashed line there shows what climate modelers have traditionally used to define global temperature, which is the average of surface air temperature over the globe in their climate models. If you hit return again, the solid line shows the measure of global temperature change that's actually used by the World Meteorological Organization and by observation groups to define global temperature change. And that's a combination of air temperature over land and seawater temperature over the ocean. We can calculate these two things in climate models, and you can see immediately, if you hit return, that there is a small difference between them. The difference is less than 0.2 degrees, but in the context of our proximity to 1.5 degrees, how near we are to 1.5 degrees, even a difference of 0.2 degrees becomes important. So it becomes very important to be very clear what we mean by global temperature when we're talking about how close we are to 1.5 degrees. And in the reported warming, in the 1.5 degrees report, we used the WMO convention of reporting warming in terms of an average of air temperatures over land and water temperatures over the ocean, because that's what's actually observed. If you hit return, please. So pulling all that information together, we reach the conclusion that human-induced global warming has reached 1 degree with a likely range, that's a 66% chance of it being between 0.8 degrees and 1.2 degrees, and that it's increasing at 0.2 degrees per decade. That's where we're at, 1 degree. If you hit return, and if we go to the next slide, this is just to stress that the attribution of recent warming is consistent with previous assessments, including the IPCC Fifth Assessment Report. If you hit return, the IPCC Fifth Assessment Report said that we'd observed 0.7 degrees of human-induced warming between 1951 and 2010. And that's shown, sorry, if you go to the previous slide, you can see that arrow there is showing the AR5 assessment. And if we go to the next slide, this is actually the figure from the IPCC Fifth Assessment Report, which shows that orange bar. That's the combination of anthropogenic forcings, the warming caused by a combination of anthropogenic forcings over the 51 to 2010 period. That's 0.7 degrees. And as you can see, it's very consistent with what we reported in the 1.5 degrees report. The reason I'm emphasizing this, if you hit return, is that what was headlined in the Fifth Assessment Report was the fact that it's extremely likely that more than half of the observed increase in global average temperature from 1951 to 2010 was caused by human activity. That was the headline, and that's showing you there, the blue arrow there is showing you how far away we are from only half of the observed warming being due to human influence. But crucially, if you hit return, the IPCC Fifth Assessment Report also said that the best estimate, that's the most likely value, of the human-induced contribution to the warming is actually similar to the observed warming over this period. So if you hit return again, that shows you that the point here that the best estimate of the human-induced warming is actually within the uncertainty range of the observed warming. So a lot of people took away from the fifth assessment report that we could attribute more than half the warming to human influence, but what they failed to realize was that was just focused on one end of the uncertainty range, and that the central estimate of the uncertainty was actually the same as the observed warming. So there's no change in our estimate of human-induced warming from the fifth assessment report. Hit return again. It's important to stress that 1.5 degrees, the 1 degree of global warming, global average temperature warming, doesn't mean 1 degree of warming everywhere. And in fact, between 20 and 40% of the world's population live in regions that have already warmed by more than 1.5 degrees in at least one season. So this puts that warming globally into context and emphasizes the fact that there will be uneven warming and greater warming than the global average in many land regions and many regions where people live. If we go to the next slide, where I'm going to wrap up. So this is going back to the SPM1 figure. We are now at 1 degree and warming at 0.2 degrees per decade. That means we're likely to reach 1.5 degrees somewhere between 2030 and around 2050 if warming continues at the current rate. You hit return, that shows you 1.5 degrees. So a crucial question which many people asked following the 1.5 degree report, well, following the Paris Agreement actually, when the 1.5 degree report was first commissioned, was what will it take to avoid more than 1.5 degrees of warming, and is it even possible? Are we already committed to 1.5 degrees of warming due to past emissions? So if you go to the next slide, this is a figure from the chapter. It's rather more technical than the figures I've shown you from the SPM. But if we just focus on the yellow line here and try to sort of ignore all the other ones, this shows the implications, what we would expect if emissions were to stop, hypothetically, in 2020. So it shows you the committed warming due to past emissions alone. And you can see it's quite an interesting behavior. We see initially a small warming bounce. Hit return, please. There's a little bit of warming immediately after all emissions cease, because some of our emissions, notably of aerosols, are actually causing cooling, and those wash out of the system very quickly, and we see a small warming response to the removal of those aerosols. But very rapidly, within a decade or so, hit return again, please, we see temperatures fall back below where they are today, and that's because methane, short-lived climate pollutant, is also being oxidized away. So we're reducing warming down to the level of the carbon dioxide-induced warming, which will then persist for many centuries. So, because only carbon dioxide accumulates in the climate system, as soon as we stop emissions, temperatures revert to rapidly, within a few decades, revert to the level that they are committed to by the combination of carbon dioxide and nitrous oxide emissions up until now, and that sets the long-term level of warming. So this is where I'm going to hand over to Mikiko to talk about pathways that would allow us to limit warming to 1.5 degrees. Having explained why past emissions don't commit us to 1.5 degrees, Mikiko is now going to take us through how actions in the future may achieve 1.5 degrees. Over to you, Mikiko.
Thank you, Miles. Then back to the